Alright, now let us look at the oblique asymptote. The oblique asymptote, oblique, how do you spell it? Oblique. Yeah. Asymptote. Asymptote. So the oblique asymptote. So for you to watch this, then you must have gone through a video of how to find your vertical asymptote and your horizontal asymptote. Vertical asymptote, where you simply need to equate your denominator equal to 0, and then you solve for x. Horizontal asymptote, you look at the behavior of the highest power of x at the bottom and at the top. Yeah. So the horizontal asymptote comes in if either this is equal to this or this is that's less than, eh? I was about to write greater than, less than the bottom. These are the only times when you're going to have your horizontal asymptote. Now, this lovely guy called oblique asymptote comes about when the highest power of x at the top is greater than the highest power of x at the bottom. For example, you have something that says f of x is equal to 2x squared plus 1 over x plus 3. So in this case, you won't have a horizontal asymptote, but you're going to have an oblique or a slant asymptote. Now, how do you actually find your oblique asymptote? You've identified to say, okay, yeah, this must have an oblique asymptote, but how do you find it? You find it by using the long division method. Yeah, the long division method, where you're going to find your quotient and your remainder, and your quotient will be your oblique asymptote. For example, taking this same thing that I've scribbled up here, so expressing this under long division form, would say x plus 3, and then we'll say root of what? 2x squared. But under long division, I would love to express the numerator in proper descending powers of x. So this is x power 2, so I must have an x to the power 1. But since it's not here, I can create it by simply saying 0x. So this x is the power 1. And then I also have my 1, which is the x to the power 0, so I'm cool like that. Yeah. So I'm going to start doing a long division as follows. Yeah. So with my long division, I'm going to say x into 2x squared. So that's like saying what? That's like saying I have my 2x squared, and then I say over x. So this is going to give me what? 2x, right? So this 2x, I would prefer to write it directly on top 0x, right, for order. So I'm going to say 2x, yeah, and then 2x multiplied by x, that's what I'm going to do next, which is going to give me 2x squared. 2x multiplied by 3 is going to give me plus 6x, like that, and then I can subtract them like that. So it's going to give me what? These guys cancel out, so it's going to give me a negative 6x. The 1 comes down, so it's going to be a plus 1. X into negative 6x, I'm going to have what? I'm going to have a minus 6 here. Minus 6. Minus 6 times x is going to be minus 6x. Minus 6 by 3 is going to be minus 18. And then again, I am going to subtract these guys. So these guys cancel out, and this one is going to give me a 19, is it? Yeah, a 19. So here I'm done, because there's nothing else that can drop from the top here. So I'm done here. So I can conclude to say what? If I have 2x squared plus 1 over x plus 3, the answer is going to give me 2x minus 6 plus 19 over x plus 3. If you're not familiar with how you divide polynomials, this is how you fully express your answer. This is how you fully express your answer. For example, let's say you are saying 9 divided by 2. 9 divided by 2 we know is 4.5. Right? 4.5. But this 4.5 can be written as follows. You can have your 4, and then you can say plus. What is the remainder when you divide this into this? Your remainder is 1. Alright? Over what you had here at the bottom, which is going to be a 2. Adding up these 2 is going to give you a 4.5. So that's typically what we've done here. So we've put the quotient here, and then we're going to say the remainder, which is 19, over the dividend that we had there. So that is the full expression. Now with the oblique asymptote, we're only interested in the actual quotient here, which is the one that we're going to have on top there, which is 2x minus 6. So we're going to say y is equal to 2x minus 6, like that. And then we're going to plot this 2x minus 6 on our xy plane, or we're going to say what? We are going to say, we're going to come up with a box like that, like that, like that, and then I can put my 0 there, and I can put a 0 there. So I can say, if I put 0 here, so it's going to be 2, 0, minus 6. So I'm going to get a what? A minus 6, right? So minus 6 there. And then I put a 0 where there is y. So 0 is equal to 2x minus 6. So it's going to be 2x is equal to 6. So x will be equal to 3. 3. So these are my 2 points. So I'm going to have something like this and like that. Yeah. And then I'm going to say what? The point 0, negative 6. I can say negative 6 is down there. So I can say the point is there. And the point 3, 0. So 3, 0 is somewhere there. So I can have this as my oblique asymptote. Oblique asymptote. And then I also had the horizontal asymptote, since it was x plus 3 at the bottom. So it's setting this equal to 0, x equal to negative 3. So this negative 3 is my vertical asymptote. So negative 3 can be somewhere there. So I'm going to have my vertical asymptote like that. So this is my oblique asymptote here. Let me indicate it. This is my oblique asymptote right here. And then this is my vertical asymptote right here. But we'll focus on the oblique asymptote. You see that guy there? That is oblique. So he's also called the slant because, you know, the slant behavior. And then you can have a more complicated question than this. Yeah, you can have a more complicated question where they can tell you to say, you have a function that says f of x is equal to x power 4 plus, let me choose that. Let me just say x power 3 plus 1 over maybe x minus 1. Something like that. Yeah. So finding your horizontal asymptote. What is your horizontal asymptote there? Okay, maybe let's start with the vertical. Vertical, you set the denominator equal to 0. So vertical will be x equal to 1. Cool. Horizontal. Now what is your horizontal? You don't have your horizontal, right? Why? Because the highest power of x at the top is greater than the highest power of x at the bottom. So in this case, you have an oblique asymptote. How do you find your oblique asymptote? Long division. So you're going to say what? You're going to say x minus 1, x power 3. Now, in lovely descending orders of x, I'm going to say plus 0x squared plus 0x plus 1. Something like that. So I'm going to say what? Let's see. I think I would rather write this on top. So I'm going to say this. Let me just rub what I have there so that I put this on top and I can express everything fully. So I can say this is x minus 1 root of what? x3 plus 0x squared plus 0x plus 1, like that. And I can get rid of everything at the bottom. Yeah. So let us do up this division. So I'm going to start like how? X into x cubed. It's going to give me what? X squared. And I would write x squared directly above this x squared here for proper order. It's going to write x squared there. So x squared times x is going to give me x cubed. X squared times negative 1, so that's negative x squared, like that. And then I'm going to subtract this guy. So I'm going to say this, subtraction. This here goes, and then this here is going to give me a positive x squared. I drop my plus 0x like that, and then I say x into x squared. This should give me a what? A plus x, yeah? X times x, that's x squared, x times that, negative x, like that. And then here again, I can subtract them like that. So this goes. This is still going to give me a plus x, but this time I have a plus 1 this side. So x into x is going to give me what? A plus 1. 1 times the x there is going to give me x. 1 times that is going to give me that. And then I can subtract here again like this. So it's going to give me what? This here goes. This here is going to give me a 2. Is it? Yeah, a 2. So before I write up my oblique asymptote, I would say, what would I say? I would say something. What would I say? I would say this. I would say I had x power 3 plus 1 over x minus 1. After I used long division, my answer was x squared plus x plus 1, right? This was my perfectly good quotient here. But then I also had the remainder of what? 2. 2 over this guy over here, so this is x minus 1. Good. But I'm only interested in my oblique asymptote, and my oblique asymptote is only found in this portion. So my oblique asymptote, which is y, is going to be equal to x squared plus x plus 1. Something like that, yeah? So I have that as my oblique asymptote. So I need to graph this oblique asymptote. I need to graph this oblique asymptote. Now, how does such an oblique asymptote look like? So I would have my y is equal to x squared plus x plus 1. So assuming it would come out, something like this, yeah? And then assuming I also had a horizontal asymptote of something like that. So my graph would either come out there, and it can either come out there. Yeah, so that is basically how you find your oblique asymptote. If your highest power of x at the top is greater than the highest power of x at the bottom, and you use long division to find your horizontal asymptote. So with your long division, simply get what you get on top there and graph it. So that's going to be your oblique asymptote or your slant asymptote.